So before we start our event tonight, I'm Anne Turnbull. I'm a Crown Diamond with Max International. And as I was saying a few minutes ago when we started the call, is that a few of us had the chance to hear this amazing speaker share some of his findings on RiboCeine last weekend. And his words were so incredible, so powerful, that we thought we needed to share what he had to say with the world and give him the time that he really deserves and needs to share what he has been seeing and learning about RiboCeine. So before we kick off the event, I want to introduce him properly. Normally I introduce him as my friend and a wonderful man and, one of the most knowledgeable people that I know, and he is all of those things. But I want to actually give you the proper introduction, a shortened introduction, because if it was the true introduction, we would be here for many, many hours. So let me just go ahead and read a little bit about this amazing speaker for tonight so that you have an idea of who you're going to be listening to. So Professor Abraham Osinubi is a medical doctor with over 34 years of clinical experience, and he has over 22 years teaching experience. He served as a sub-dean in the Faculty of Medicine, and he had 3 separate terms as head of anatomy, including at the University of Lagos up until last year, 2020. He is an external examiner to several universities, including Ghana and India, and he's a visiting scholar in South Africa. Professor Osinubi was the Secretary General of the Endocrine and Metabolism Society of Nigeria for 4 years and the Vice President for 4 years. He is currently the Vice President of the Lagos University Medical Society. Dr. Abraham Osinubi has successfully supervised 16 doctorate theses and numerous Masters of Science projects and dissertations. 8 of his students are already professors. So this is the professor of professors. He has given birth to 8 other professors already, and I know he's not done yet. He is the Foundation Editor-in-Chief of the University of Lagos Journal of Basic Medical Sciences. He is a fellow in 5 medical bodies: the American College of Endocrinology, the Anatomical Society of Nigeria, the Society of Experimental and Clinical Anatomists, and Academy of Medicine Specialties of Nigeria, and also a fellow in the Nigerian Academy of Medicine. He has authored over 120 scientific publications. He co-authored the first national clinical practice guidelines for diabetes management in Nigeria in 2012. ResearchGate acknowledged him as one of the most cited authors in his field in December 2015. Medicine is not his only passion, though. He is also a businessman. He is an entrepreneurship developer. He is currently mentoring over 5,000 young entrepreneurs in team building and business development. He is the maiden and current executive director of the University of Lagos Business School, and he is simply an amazing, amazing individual in every respect. I think we would all agree that this is a man to be reckoned with, and I am so excited to welcome him to today's call. So, Prof, please take it away. Oh, let me make sure I've also enabled you. Yes, good. You're with us. You're still on mute. All right, Prof is just getting his slides up and running. You are welcome, sir. Yes, I think we can show him some love. Let's show Professor Osinubi some love. Welcome him with a big warm round of applause in the chat. A big welcome to Professor Osinubi. one of the most amazing individuals I've ever had the pleasure of meeting in every single respect. Really an incredible man. And he has done all of us a tremendous, tremendous service with his work on RiboCeine. He is just, you're going to hear from him directly. So Prof, I hope you are getting settled. Welcome, sir. Lots of welcomes to you in the chat. Amazing. Amazing. Okay, let's see if you can unmute yourself. There you are.
Oh, okay. Yeah.
Great.
And thanks, Anne. Yes. Good evening, everyone. Good morning, depending on where you are, afternoon. And by the way, thanks for that introduction. I'm honored. Hope you can see my screen.
We need to see your slides in presentation mode, I think. We can only see the...
Yes.
Yes.
Okay.
Beautiful. You're all set, sir. We can see you very well. Go ahead.
Okay, good. So once again, good evening. I will be sharing with you 7 of our publications from our laboratories in Lagos. So I won't be able to share all the papers that we have from Nigeria, but these are 7 papers from the work we have done in my own laboratory in Lagos, Nigeria. So it's titled The Power of RiboCeine. But before going to the papers, we're going to a brief introduction of the anatomy of humans. Every human being, no matter the number of cells that we have counted as scientists, develops from one single cell, eventually to 2 to 4 to 8, 16, 32, and so on and so forth, until we have a fully developed humans made up of over 70 trillion cells. As today, we've counted over 250 cell types now that we know of, distributed all around the body. But guess what? The greatest enemies to all these cells are the free radicals. Perhaps you are here today. Oh, you've heard so much about free radicals, and you think in your own knowledge that you have that the world free radicals have been overflogged, overlashed, overbeaten, over talked about, overrated. Perhaps you will change your mind today. Let's quickly look at what others before me have done. This paper published some years backward, 1995, talked extensively about the role of free radicals in disease. And it may interest you to know that as at last year, about 70 million people died of heart disease. About 10 million people died of cancers. About 6 million people died of pulmonary diseases, and about 1.5 million died actually of diabetes. Then this paper also published in 2018 extensively explained the role of free radicals, especially in chronic diseases, heart disease, including stroke, heart attack, hypertension, cancers, pulmonary disease again, and diabetes, essentially. This is also of interest, showing us, the distribution of the deaths we have worldwide. In a year, we lose about 56 million people worldwide. Every single hour, we lose about 6,400 people worldwide. And every day we lose about over 155,000 people will die. And the distribution is as follows. heart disease, 17 million, cancers, about 10 million, diabetes, about 1.5 million, and pulmonary disease, about 6 million. And almost all of these have been associated, because most of them are chronic diseases. Almost all of them have been associated with free radicals. So it means free radicals will continue to be extremely important to us. So let's now go back to the free radicals themselves. What are they? Basically, they are molecules with unpaired electrons within their body cell, not necessarily on the outermost, but importantly to us as human beings first, and then secondly, as scientists, a medical scientist for that matter, is that these substances are highly reactive and highly unstable. However, in an attempt to achieve stability, they react with neighboring substances and attempt to actually take electrons, which I call them thieves, because they steal electrons to achieve stability. Unfortunately, instead of them achieving stability, they never actually achieve stability. But by the time they succeed in taking electrons or snatching, as it were, electrons from neighboring substances, those substances also become reactive species themselves. So a cascade of reactions is set in motion and will snowball to as many reactions as possible, creating massive destruction of neighboring tissues, neighboring cells. So for example, this is a normal cell here, and then we have a cell that has been attacked by free radical. By the way, it has already been established that, by this great biochemist based in California, Bruce Amis Nathan, discovered that in a single day, every cell in our body, is actually hit by a free radical as many times as 10,000 times. Again, I'm taking that for record purposes. And every single day, a single cell in our body is actually hit by as many times as 10,000 times by a free radical. So you can imagine, and we have 70 trillions of cells. So you can imagine the number of bombardment we actually have from free radicals. Now, it is not only about stealing electrons or snatching electrons. On my own left, you see a normal protein. But look on my right, what sometimes in an attempt to actually snatch electron is not possible, but the proteins are denatured. A protein that is denatured can never perform the same function as one that is normal. For example, you can imagine the brain, for example, gets as much as 20% of the oxygen in the human body. By the way, what needs to, there are certain conditions that must be met before we have attacks from free radicals. Number one is that the oxygen must be available. Number two is that very often there will be free fatty acids. The brain, for example, has billions of cells coming together, synapses, and we have oxygen in abundance in the brain anyway. 20% of the body oxygen is consumed by the brain. So you have oxygen, you have polyunsaturated fatty acid in high quantity in the brain. And therefore, the brain is unusually prone to being damaged by free radical. So I'm not surprised if you Google now, you will find that virtually all ailments, almost all chronic ailments of the brain will respond actually by raising their glutathione level. For example, Alzheimer's, Parkinson's disease, these have been well documented. The liver produces most of the free radicals in the human body. It's the factory. The liver also receives 20% of the oxygen of the human body. So the panacea, the substrate, the pedestal on which free radical attack is already there. The kidney receives about 7% of the oxygen in the human body. So it is also prone to free radical. Of course, the heart and the blood vessels are prone to free radical damage. The germ cells, because they are highly active, they replicate a lot. So you have a lot of polyunsaturated fatty acid from the membranes. So the germ cells are also unusually prone to free radical damage. For example, the sperm cells. The middle piece of the sperm cells have a lot of mitochondria. So there are a lot of cells. Oxygen is there, and the free fatty acids are also in abundance. So already the panacea for free radical attack is there. DNA as well, rapidly, because the DNA, because of protein synthesis, DNA is rapidly made in virtually every cell in the human body. So DNA too is also prone to being damaged. As a matter of fact, we now know that the older you become, the shorter the telomeres. The telomeres are like the terminal aspect of the DNA. And as you grow older, these telomeres are gradually being damaged every single day. And as you grow older, they get damaged, your lifespan gets shortened, and senescence come into place, and eventually death. It means that theoretically now, if you are able to stop free radical damage, you may live forever. But of course, you are knowing that is not possible to live forever, but you can actually tone down the effects of free radical damage on your DNA. Blood cells are rapidly dividing cells. Immune cells are also rapidly dividing cells. And because they are in abundance, a lot of polyunsaturated fatty acids in their membrane. So these are cells that are highly prone to free radical damage. Well, people have said that oxygen may be the most important thing, but I can tell you, there is something on the same level with oxygen that we are talking about today, and that is glutathione. If you have enough oxygen in the human body and you don't have glutathione, that person cannot survive. I can tell you that for free. Glutathione is now regarded as one of the essential substances to survive. You cannot be alive without glutathione in your system. In fact, every living thing needs glutathione. Plants, humans, animals, they need glutathione to survive. If you Google this quickly, you will find one thing quickly. Glutathione is the most powerful antioxidant God has created in us. As a matter of fact, your body spends minimum of 6% of ATP that you produce to run your body effectively on the manufacturing of glutathione. That underscoring the importance of glutathione in the human body. It is the only antioxidant that replenishes and recycles itself. Other antioxidants, when they scavenge free radicals, they themselves become free radicals, unlike glutathione. Once glutathione has done its work, it becomes oxidized glutathione, but it doesn't become a free radical, unlike others. It is the only antioxidant that also helps convert other antioxidants back to their reduced state. Underscore. And therefore, many of us, including me, have called it the mother of all antioxidants, the gatekeeper of the human body. And as at today, the most critical molecule, the most important molecule in the human body necessary for perfect health is glutathione. If I'm given just one chance today to check any human being, the current status of health, the first thing I will most likely mention is glutathione. It's therefore the great protector of the cells and the superhero of all antioxidants. This is just showing us briefly. I know there are many of us here who are not scientists, but I will try not to be as scientific as well. But I'm sure you can see vitamin C on my screen. You can see vitamin E. What all this just means is that when vitamin C, as good as free radicals scavenging effect that it has, both vitamin C and vitamin E, when they remove free radicals, they themselves, they become free radicals. They have to go back to glutathione to help them out. And that's exactly what this glutathione is doing, helping them to convert, for example, oxidized vitamin C that has done its work, but instead of becoming normal, it has become a free radical. So you know what this means in real time? It means if you continue maybe high dose, a 1,000 milligram daily of vitamin C, you may actually be doing more harm than good, because eventually you will generate a lot of free radicals in your body from the oxidized vitamin C, especially if you don't have adequate amount of glutathione. So the presence of glutathione will help your vitamin C, your vitamin E to actually function effectively. I itemized this way back in 2016, talking about cardiovascular diseases, heart diseases, talking about kidney diseases, metabolic diseases, pulmonary disease, even diseases that affect our reproduction, cancers, the high, overdosage of some chemicals. Almost all of them have something to do with either low level of glutathione or high level of free radicals. These have been well documented as well by several other authors. Now, let's quickly, before I go into my own papers, this paper was published this year, and it itemizes and highlights the effect of glutathione on cardiovascular diseases. The same thing on the role of glutathione in cancer development. And as a matter of fact, it has been documented, even as of this year, that look, you can actually use the level of your glutathione to know whether you are prone to cancer or not. Because the higher the level of your intracellular glutathione, the more unlikely you are prone to cancer. This has been well documented by other authors even before me. Then this talks about diabetes. I won't bother to label it now, because that's where I'm going to major on much later. That look, glutathione has so much to play either on the development of diabetes or on the management of diabetes, either in terms of managing the diabetes itself or its complication. And lastly, on pulmonary disease, COVID, for example, it has been well documented that your level of glutathione will actually affect your response to COVID organism. It will affect also the management. It will also affect the complications. It will also affect the outcome, mortality, morbidity, based on the level of glutathione you actually have. A lot of authors have documented this. But there is a bad news quickly. The bad news here is that as you age, your glutathione level goes down. By the time people are 50, 60, they would have lost, unfortunately though, over 50% of their glutathione level. Unfortunately, as well as the glutathione level is going down, something is rising up, oxidative stress. And I can tell you, accompanying the oxidative stress is usually chronic diseases. The second problem about glutathione is that glutathione is a highly fragile molecule. So it's not attractive to take pills containing glutathione, unfortunately. It will largely be destroyed by the enzymes in the mouth, enzyme in the stomach, enzymes in the intestine. Also destroyed largely by the acid, in the stomach, meaning that it is not going to be bioavailable in sufficient quantity if taken orally. So that's the challenge we are going to have. The other challenge is that, okay, good, you can take it intravenously, but when you take glutathione intravenously, it means that you are not taking the natural glutathione. The one God has given you, it of course means that it is synthetic. And we are suspecting that it could be counterproductive after some time, because you are actually bypassing the negative feedback mechanism when you take it intravenously. So it's not also attractive, apart from the fact that it is highly expensive. Now, the solution came through the invention of Professor Albert Nagasawa, a professor of biochemistry, a professor of pharmacology in Minnesota University. After 25 years of solid research, he came up with what we now call known as RiboCeine. And quickly, because glutathione contains 3 amino acids. By the way, glutathione is a small molecular weight amino acid, 307.3225 gram per mole. That is the molecular mass of glutathione. So it's really very small. And it contains 3 amino acids: glutamic acid, cysteine, glycine. Luckily for humans, 2 of these amino acids are in sufficient quantity in the human body. That is glutamic acid and glycine. However, cysteine, especially under certain conditions, we now categorize cysteine. Normally, we categorize cysteine as non-essential amino acid. However, we now call it now conditioned non-essential. Conditioned in the sense that because cysteine is used in several pathways in the human body, and because, again, it is so fragile, it is also easily destroyed because of the sulfur hydride bond. So under certain conditions, for example, under stress, under ill health, you just have to take cysteine in. And that is the advantage used here. So once you introduce a lot of cysteine molecules into the human body, the normal body should actually be able to make a glutathione from cysteine, glutamic acid, and glycine. Like I said, you need to protect cysteine. And what Nagasawa and his team did was actually to combine cysteine for protection with ribose. Under normal circumstances, ribose and cysteine will naturally condense to form RiboCeine. RiboCeine gets inside the cell. By solvolysis, they will separate into ribose and cysteine. Ribose, of course, is not wasted. It's used in making ATP, okay? And then cysteine is mobilized together with the other 2 amino acids to make glutathione. And a lot of studies, even before mine, has been done to confirm that RiboCeine actually raises the intracellular glutathione level. And in those days, as at 1987, what most people were using then was NAC, N-acetylcysteine. When this was compared with NAC, it was found that in the liver cells, RiboCeine was 300% more effective in raising glutathione level inside hepatocyte, inside the liver cells. Now, let's look at quickly the studies in my own lab. I came across RiboCeine in year 2015, and by 2016 December, 2015 December, we started a lot of work. Many of them we started publishing by 2016. But we did this review. We call it the battle between free radicals and antioxidants, how glutathione can help prevent diabetes and its complication. What exactly the fallout of this research was that there are majorly 2 glucose transporters. Transporters are agents in the human body that convey glucose from outside the cell, that is within the blood usually, into the cell. Glucose will not just go inside the cell, no. It needs to be carried, it needs to be ferried, it needs to be conveyed inside the cell. And usually it is these transporters labeled, there are many, but the most important for today's is glucose transporter 1, glucose transporter 4. Glucose transporter 1 is located on the cell membrane, but unfortunately, it's not much. The glucose transporter 4, that is a lot in abundance, resides within the cell, within the cytosol. So it needs to move onto the cell membrane, okay, so that it can allow glucose to come inside the cell. We have discovered that one major thing that allows the movement of glucose transporter 4 from the cytosol, that is from within the cell to the cell boundary, so that it can open the gate for glucose to come in, is actually dependent on glutathione. The implication of this is that if there is no adequate amount of glutathione within the body, you may be flogging your patient with insulin, with oral hypoglycemic agent, and you may not get good response because the translocalization of glucose transporter 4 from the cytosol to the cell membrane is highly dependent on the availability of glutathione. And it has also been documented, even by authors before me, that look, the so-called pre-diabetic stage that may later end up with diabetes is actually dependent on either low level of glutathione or high level of free radicals. What that means is that sometimes pre-diabetic stage can develop for 10, 20 years, even before diabetes eventually develop. It means that we can actually move in at this stage and slow it down or prevent it, as a matter of fact, by doing the right thing. So low level of glutathione will result in reduced or zero glucose transporter 4 response to insulin. And this may lead to high level of blood glucose, and that may lead eventually to full-blown diabetes. Then the next thing we did is this. We compared the normal oral hypoglycemic agents, okay, with RiboCeine. So we had this group called non-diabetic. These are normal rats. The second group, we gave distilled water. They are diabetic. By the way, we made these animals diabetics by destroying the beta cells of the pancreas that the beta cells of the pancreas, they produce insulin. Insulin is supposed to reduce the blood glucose level. So we destroy the beta cells by giving these animals streptozotocin. Streptozotocin goes inside the pancreas, destroy the beta cells, and render these animals diabetes. Of course, we lost some animals because the sugar level went so high. Then these animals, some of them were given water as control, some of them were given insulin, some of them were given RiboCeine, some of them were given vildagliptin, some of them were given glibenclamide, some of them were given metformin, some of them were given glipizide. And let's look at the results that we got. We checked the blood glucose, okay. Apart from checking these animals, by the way, they were pregnant animals. So we are checking the blood glucose. Eventually, we also did on day 21, we did cesarean section for these animals. So we also monitor not only the mother, we also monitor also the litters. That is, in human being terms, we monitor both the mother and the babies. Of course, we use the dam for the mother in animals. We use litters for the animals. So again, for the sake of clarity, we've also measured hormones, the progesterone, the estrogen, the luteinizing hormone, the FSH, the prolactin. We measure all sorts. We also measure a lot of what we call the markers for oxidative stress, the enzymes. For example, what we call the SOD, the catalase, the MDA. Then also we monitor the fetal well-being, okay, of all these animals. We measure the number of fetuses, we measure the weight of the fetus, we measure the weight of the placenta, we measure the components of the placenta, we measure the ovary, we measure the length of the litters. And the conclusion, to save time, is that to the best of our knowledge, this was the first study that introduced the potential benefits of D-ribose L-cysteine, known as RiboCeine, as an effective oral hypoglycemic agent, which could serve as a potent adjuvant in the management of diabetes in pregnancy. Of course, a lot of studies need to be done before we can extrapolate this to humans. I am very, very careful and cautious to say this. This study had been done in pregnant animals, so we cannot directly extrapolate this to humans. But suffice to mention that we got a lot of good responses in terms of hormones, in terms of free radical monitored, in terms of toning down the effect of free radicals on these animals, even the blood glucose itself. For example, quickly, at least let me mention this. Group C, Group B, for example, they are diabetic animals. Look at the blood glucose level, and look at the blood glucose level both for insulin and D-ribosyl cysteine. They are parallel. So it means that there are some advantages of having D-ribosyl cysteine, and this has been published. So you can check the toxicological reports. 2018, we eventually published, because when we started in 2016, the first set of results we got, we were confounded. Look, how is it possible that D-ribosyl cysteine, this ribosine, is doing all this? We repeated the experiment, and eventually we published in toxicology report. It's available free online now. The next experiment we did was to look at the liver. The liver is the greatest producer of free radicals. So we decided, let's look at the liver. We destroyed the liver of these animals using aluminum trichloride. Okay, and then we place these animals on RiboCeine, and we look at the effect. We measured hematological parameters that included the PAC cell, the hematocrit, the white blood cell count. Under the white blood cell, we did a lot of other parameters, how much blood these animals were having. Okay, we also check the liver enzyme. Normally, when the liver is destroyed, because of the destruction of the liver, a lot of the enzymes are let loose into the body circulation. They are not supposed to be outside the liver, but we use that to measure the extent of damage to the liver. For example, the PAC cell volume, if you look at it, the blood level of these animals, when you compare those that had RiboCeine with the animals that did not have RiboCeine, it is very much different. Animals that had liver destruction plus RiboCeine actually almost went back to normal level of blood level of white blood cell count. The same thing, we look at the enzymes in the liver. We look at the enzymes in the blood. For example, alanine transferase. This group C is the group that had liver destruction plus RiboCeine. Look at the enzyme, see going down, see very low. But look at the group that had just liver destruction alone, and look at the enzyme really very high. The same thing we did the aspartate transferase is almost replica of what we had in alanine transferase. So the RiboCeine brought down the liver enzyme, showing that there had been some elements of repairs that has been done following the damage done by aluminum trichloride. We also check aspartate transferase to save time. We also check the serum alkaline phosphatase. Again, the group that had RiboCeine actually had the lowest level of alkaline phosphatase, unlike the group that had liver destruction alone, without any without doing anything to try to mediate it. The same thing, the serum protein level, of course, the liver synthesizes a lot of proteins. You can see that that of the group that had liver destruction plus RiboCeine had as a matter of the highest level of protein, unlike the group that had just liver destruction had very little protein being manufactured. So showing that following liver destruction, there has been a lot of regeneration following the effect of RiboCeine. The same thing with bilirubin. Bilirubin level is highest in a group that had just the toxins, the chemicals that destroy the liver, unlike the group that had both destruction and RiboCeine had very little bilirubin. We concluded that RiboCeine protects the liver from the toxic effects of this chemical agent that was used. The next thing is that we did the same experiment we repeated with the kidney. The kidney received about 7% of the total oxygen consumption by the human body. So it means that the kidney has a lot of oxygen. And like I said earlier, the panacea for free radical damage is to have oxygen available in good quantity and a lot of free fatty acid. The kidney, each kidney has a minimum of 1.5 million nephrons. So you have a lot of cells coming together and you have a lot of oxygen. So already you have the substrate for free radicals to thrive and wreak their havoc. And that is the reason why we pick the kidney. And of course, end-stage kidney state is becoming more and more. Unfortunately, again, the commonest cause of end-stage kidney in the world is diabetes. So again, we destroy the kidney using aluminum this time around again, and then we monitored the creatinine level, the urea level, the uric acid level, the potassium level. These are what we normally call the kidney function test. The creatinine, if you come, then we also, after destroying the kidney, we also gave D-ribose L-cysteine, which is RiboCeine here. You can see here the creatinine level in aluminum chloride group is really very high compared to normal. The urea high, the uric acid high, but look at the group that had aluminum chloride and RiboCeine. They are almost as good as that of control. As a matter of fact, the uric acid, the potassium, okay, the urea, the creatinine are even lower than the control following application of both aluminum trichloride and RiboCeine. Then we also monitor the packed cell volume, the white blood cells, the neutrophil, the lymphocyte under the white cell count. I mean, the same pattern again. It was as if there was no destruction of the kidney, because the kidney actually has a lot of part to play in manufacture of red blood cells because of the erythropoietin that is manufactured in the kidney. So if the kidney is not functioning well, that person is not likely to produce a sufficient quantity of blood cells. And then we concluded that RiboCeine protects the kidney from the toxic effects of this chemical agent used, aluminum trichloride. The next thing we did was to expose the testes of rats to irradiation. Somehow, the dosage of the irradiation we have used here is the normal dosage that we health workers will get exposed to every day. You know, the level we have used. So we subjected these animals to irradiation. And then we monitor the sperm count. We monitor the sperm morphology, that is how the sperm look like. A normal sperm should have one head, one tail. But under certain conditions, they can become abnormal, like exposure to radiation. Some can develop two heads, some can develop two tails. You know, some can develop extremely short tail, and some may not even be able to. A normal sperm should be able to move. Okay. So that's why we also, apart from monitoring or checking the sperm count, the number of sperm that are left, we also monitor whether they are moving or not. And this is our results. This is the normal. The first group is the normal group. No radiation. You can see here the number of sperm we have here, the sperm morphology, the percentage that are normal, the percentage that are abnormal. But look at following radiation, the sperm count reduced from 690 to 320. Okay, that is per million anyway. Then the sperm morphology, in terms of normal percentage, 87%, about 90% were taken to be normal. but less than 50 became normal. But if you, after following destruction or exposure rather to radiation, then having had it either before, okay, or concomitantly with the ribose, look at what we have here. For example, it's almost the same, very, very close to normal. So these are, for example, where I place my cursor now, that is group 1, 2, 3, 4, 5, the fifth column. Here we have both exposure to radiation before giving then D-ribose L-cysteine. The sperm count went up to 500, okay? The sperm morphology in terms of percentage normal went to 72 from 47. Then the abnormal percentage went down from 52 to 27. This is what we got from this. Then we also check G6PD, okay? That is glucose 6-phosphate dehydrogenase. This is an enzyme that has to do with regeneration of glutathione. Following exposure to radiation, this is what we got, low level of G6PDH. Meanwhile, by the time we then put these animals on D-ribose L-cysteine, there was a little bit of improvement, okay? And then a lot of improvement with the fourth group, that is radiation before D-ribose L-cysteine, that is RiboCeine. This is what we got. And then we also, apart from that, we measure the MDA. MDA is like, MDA is a marker for the level of oxidative stress, because let me tell you how we generate MDA. When free radicals attack lipids, they generate a lot of substances. One of those substances is MDA. And the funniest thing about MDA also, we go ahead to react with other substances of the tissues, including the nucleus, including nuclear proteins, thereby forming what we call adjuncts with nuclear protein, incapacitating them, making them inactive, making them not to perform the functions that which they were created to perform. And that is why MDA is so important. In group that receive radiation, look at how the MDA went up. But meanwhile, in group that receive radiation together with D-ribose L-cysteine, of course, the MDA went down. And of course, the group that had just D-ribose L-cysteine, I mean, the MDA was even below what we got for normal. And we have published this in the Journal of Nuclear Medicine in 2017. So you can also have a look at this publication. Then the next thing we did was the last one we did was destruction of the testes following radiation. This time around, we now use chemical agents, because why are we using chemicals? There are over 80,000 chemicals that are circulating in the world. Unfortunately, less than 10% of these chemical agents have been tested for developmental toxicity. Highly unfortunate. And every year, new chemicals are added. And that is why I always say that the bodies of water are polluted. The air is polluted. The soil is polluted. Everywhere is almost polluted. And that is the reason we are using chemical. Then having destroyed the testes with aluminum again, we check the sperm count, okay, of the animals that had just pure destruction. Look at how the sperm count went down. Look at the third group is the group that had destruction of the testes in addition to RiboCeine. Look, I mean, almost we had normal level of sperm count, even following the application of toxins. The same thing with morphology. In terms of normal, how the sperms, how they look like, even after destruction, we found that, look, D-ribose L-cysteine is able to protect the testes. Then we also did motility tests. Are these sperms moving? Are they moving at the right rate? The same thing again. We saw protection of motility in the group that had destruction and D-ribose L-cysteine, RiboCeine. We also monitored the testosterone level, which is essentially the male hormone in these animals. This is back to normal. Unlike the one that had just aluminum chloride following destruction, is of course not producing enough testosterone. These animals, of course, are most likely infertile. And this is showing us, this is what we saw on when we cut the testes open, we stain them, and then we look onto them. This, for example, where my cursor is are the cells that produce testosterone. Okay, we call them the interstitial endocrinocytes or the Leydig cells. They produce, you can see those spaces. Unlike this is a group that had both the aluminum chloride and RiboCeine. Okay, and we even use really low dose of RiboCeine. For example, we use just 30 milligrams per kilogram body weight of RiboCeine. But look at almost intact. Everything is intact. You know, the interstitial cells are intact. But look here, the interstitial cells, are almost off completely. And if you look at the lumen in the group that had just aluminum chloride has become enlarged, meaning that the germ cells have become thinned. Unlike the ones on my right, look at the germ cells intact. That is due to the effect of the RiboCeine that was added concomitantly with the aluminum chloride. And this has also been published in the JBRA Assisted Reproduction Journal. It's available also online. And we conclude that RiboCeine treatment significantly attenuates the aluminum-induced testicular toxicity. Then the next thing we did was also to expose the ovary to radiation. Why are we using ovary? Why are we using testes? Testes and ovary have something unique about them. They house the germ cells, meaning that they house tissues that are highly replicating, and highly replicating cells are highly susceptible as well to radiation, and that is why we expose this ovary onto, and we monitor again the MDA. The MDA is so high in the group that had radiation alone. The group that had radiation, for example, if you look at group D had D-ribose L-cysteine, RiboCeine before radiation. Look at, the MDA is normal. You know, the group that had radiation alone, the MDA is up. The MDA, like I said earlier, is an oxidative stress marker, but it's unique in the sense that it also creates oxidative stress itself by reacting, not just creating oxidative stress itself, it also reacts with nuclear protein, thereby incapacitating a lot of proteins in the human body. We look at the glucose 6-phosphate dehydrogenase enzyme as well, an enzyme that has to do with the conversion of oxidized glutathione back to normal cell, back to normal levels. For example, when glutathione has scavenged free radicals, it becomes oxidized, the so-called GSSG. Like I said earlier, the oxidized glutathione is not a free radical, unlike other antioxidants that will become free radical. The same pattern with this, we also check this enzyme known as glutathione peroxidase. Glutathione peroxidase, what does it do? It uses glutathione to mop up free radicals, converting them to water and oxygen. That's what it does. In these animals that had radiation alone, for example, group B, look at the enzyme, very low. But look at the group that had, group D, for example, had RiboCeine before radiation. This is in the ovary now. Look at the enzymes are normal. And we concluded that RiboCeine protects the ovary from the deleterious effects of radiation. Then We then look at this. This is really very interesting now. We quite realize that over 80% of individuals in their lifetime in the whole world will develop low back pain. And a lot of low back pains are actually due to degenerative ailments. Let me take that again. Over 80% of the world population will develop low back pain at various times in their life. However, the point incidence of low back pain is over 30%. Meaning that at any point in this world, at any point in time, in either now or in the past, somebody must, 30% of the world will be having low back pain. So we are talking of a lot of money spent, a lot of man hour wasted, out of work, out of job, out of school because of low back pain. So what did we do? Quickly, we got rabbits, we got normal rabbits, punctured a lot of them at the intervertebral discs, and we check under the microscope. After puncturing, we saw that degeneration has ensured. Then what do we do? Many of these rabbits, we divide them into groups again. We place them on sulforaphane. We place some on sulforaphane and RiboCeine, and we place some on RiboCeine. We got very, very, very interesting results. Now, to compartmentalize things now. The one on my left up is the normal cells. These are the intervertebral disc. So when I say we puncture the intervertebral discs, by the way, are those discs like they are cartilage. They are in between our vertebrae. They serve as cushions. Okay, they serve as speed breaker, as it were. You know, like when you jump from a height, what does not allow you to feel so much pain, what also protects your spinal cord, is because the force is actually absorbed by the intervertebral disc. And so when people have pains and things like that, sometimes it could be as a result of, it's possible you have heard of herniation of the intervertebral disc. When there is herniation or when there is degeneration of the intervertebral disc, it will allow a bone above and a bone, that is the vertebrae above and below, to come together. And because of movement, you will be feeling pain. And not that, it will be also when the bones come together, the vertebrae come together, they compress on the nerves. And therefore, very often, people have that pain radiated to the back of the leg, which sometimes you call the radiculopathy, okay, or the sciatica. So what did we do here? Having destroyed the intervertebral disc, this is normal disc. You see here, look at where my cursor is. This is normal intervertebral disc. But look at the one that has been destroyed. Okay? You can hardly see any cells. But look at the one that we put on RiboCeine. Okay? Look at the RiboCeine after destruction. So it's almost like normal. Not just that. We also counted the chondrocytes. The chondrocytes are what are the cells that secrete, we call them chondrocyte-like cells. They secrete the contents of the intervertebral disc that ensure that intervertebral discs are still able to perform their functions effectively as shock absorbers. And we have published this work in 2017. It's available free, where we concluded that we saw increase in chondrocyte-like cells in the annulus fibrosus. Annulus fibrosus and the nucleus pulposus are what are the components of the intervertebral disc that actually serve as cushions for the vertebral column, not allowing it to collapse, not allowing the intervertebral disc to actually move so much that it may dislocate or harm the vertebra, the spinal cord. So in short, we also saw the regenerative potential of the two agents that we have used here. And lastly, The last work we did, that I'm going to talk about, is that it has to do a little bit with treatment of cancer. One of the major treatments that we use in the treatment of cancer, one of the major agents that we use in the treatment of cancer is known as doxorubicin. So we place some animals on doxorubicin, and then we monitor their sperm. We monitor the enzymes. We also monitor the hormones, the testosterone. That is what we mean by steroidogenesis, the synthesis of testosterone. Testosterone is essentially the male hormone, okay? And then we also measure the redox status, that is how much free radicals has been generated from the doxorubicin that we gave. And we got some fantastic results. And we concluded here that doxorubicin impairs spermatogenesis, that is formation of sperm. And also, it also limits, okay, the synthesis of testosterone. We also found out that doxorubicin actually generates a lot of free radicals. However, we saw one important thing, that look, when you also put these animals before you start your doxorubicin, for example, you place these animals on RiboCeine, you are going to have very, very little destruction of the testes. You are going to have very, very impairment of the synthesis of testosterone. And good enough, we have published this as well in 2019, where we concluded that since the testis is susceptible to chemotherapy-induced oxidative damage, this study actually provides evidence that may open a new pathway for the management of cancer in such a way that allows preservation of male reproductive function. And the reason why this is so important as of today, we have not been able to have a drug that will just affect just the cancer cells. Very often, when we use either the chemotherapy or the radiotherapy actually destroy both normal and abnormal cells. So we must find a way of actually protecting the normal cells. In conclusion, the science behind RiboCeine, it is sound, it is authentic, and it is contemporary, and it is apt. Scientia potentia est. Knowledge is power. When you have the knowledge and it throws more light, and the knowledge activates in you that power, and that power brings with it light. And RiboCeine is patented, is available only from Max International. Now that you know the science behind RiboCeine, there is no substitute for good health, ladies and gentlemen. Health is our greatest possession. We have a duty to procure, to protect, and preserve it. Our future depends on maintaining a sound mind in a healthy body, because a sound mind in a sick body is a prison for the mind and soul. May your body not be a prison for your mind and soul. May every one of us enjoy long life and perfect health to match. Love you all. I thank you for listening. Thank you for watching. God bless you all.
Wow, Prof. Oh my goodness, that was incredible. Oh, the comments are going crazy. My goodness, of course, everyone wants to know how they can listen again many times. We have it streaming to Facebook, so we'll be sharing that. This was really, really fantastic. So I know now we can all understand why I said that Professor Osinubi is one of the most amazing men that I've ever met. He's really incredible. So Prof, let's go ahead and take a few questions. If anyone has a question or two, you can go ahead and just either type it into the chat or just say me, I have a question, and I can unmute you, okay? So if you want to ask a question, you can either type it into the chat or you can say, I have a question in the chat, and I will unmute you so that Prof can answer a couple of questions. We still have lots of wows and amazing comments coming in, Prof. You are just, you are something, I'm telling you. Okay, so let's see. Banjo has a question. Okay, so let me find you, Banjo, and you can go ahead and ask the question. Okay, so you can unmute yourself, Banjo, and ask your question. You have to accept my request to unmute you. Okay, if you don't accept my request, then we won't be able to hear you, or else you can just type into the chat. Okay, so there's a question. I'm not sure, Prof, can you see all the questions as well?
Yes, I can see some.
Okay, there's a question about RiboCeine. Is it capable of healing or reversing fatty liver? Maybe you can take that question.
Okay.
Yes.
Yes, the liver is the factory of the body. What RiboCeine would do is to help in not allowing the progression of the ailment. However, it is also possible that it reverses it, but it's not going to be the only thing you are going to be doing. We are also going to look to the causes of the liver disease. If, for example, the liver disease is often in most climes is usually secondary, not always though, to alcohol, excessive intake of alcohol. So it means that individual also must also stop the alcohol. So you cannot be taking RiboCeine alone and then you are still you continue to consume a lot of alcohol and expect that the liver disease will go. No, you've got to stop that. And of course, you've got to take whatever your medical doctors, your physician has recommended for you, please.
Great, amazing. Thank you so much, Prof. We had a question about edema as well. That was from Banjo. Let me see the question here. Maybe you can just talk generally about, I'm just looking for the question. Maybe you can talk generally about
sickle cell?
About edema. Do you see which of our products is good for edema?
Okay, you see, edema is not a disease. Edema is a symptom. Oh, let me tell you how edema arises. Fluid that is supposed to be inside the cell compartment, another compartment, is in another different compartment. So it can result, for example, from kidney problem. The kidney is supposed to remove the waste. If the kidney is not functioning well, there will be edema, especially the edema of the face. If the liver has problem, there will be edema. If the heart has problem, there will be edema. So edema is not really a diagnosis. It is being caused by something. So we need to know the cause before we talk about treating it.
Okay, fantastic. Now, yes, there is a question about sickle cell. Do you want to talk about sickle cell in general?
Yes. Funny enough, a lot of studies, one of the major, in fact, not one of the major, the major antioxidant that is used by the red blood cell is actually glutathione. What allows the red blood cells to maintain the cell membrane, the integrity of the cell membrane, is actually glutathione. Without adequate amount of glutathione, red blood cell will not be able to maintain its membrane. So the membrane will collapse. And a lot of studies have been done. When they place the red blood cells within a lot of medium that has a lot of glutathione. Normally, red blood cells lifespan is about 120 days. But we have found that in people with sickle cell disease, the lifespan is not up to 20 at times, 30. Hardly do you get to 40. However, it has been well documented in literature. You can Google that when red blood cells are exposed to adequate amount of glutathione level, you can actually prolong the lifespan of those red blood cells to as high as 60, 80 in sickle cell. So it helps. There is no doubt about that. When you have adequate amount of glutathione by raising the blood level of glutathione using RiboCeine, there is no how you will not have good rest. The study has been done already.
Beautiful. Yeah. And I know we see a lot of people who have great results with sickle cell as well. And of course, as always, and just like Prof has been very careful through his whole presentation, but as always, we never talk about RiboCeine or any Max products treating or curing any disease. They are not a substitute for any medical care. They are not a substitute for medication. If anything, they will help regular medications work better by helping with the absorption. So please remember to always consult your doctor. I know we have a lot of medical personnel on this call as well, and I know there's a lot of questions. So the next set of questions has to do with kidney. Someone is asking about kidney transplants. Can RiboCeine help keep them going? And then someone else is asking about specific antibiotics, and then about the kidney and having. I'm going to type that one into the chat for you, Prof. But maybe you can just talk a little bit about kidney, please.
Okay. To start with, the kidney uses 7% of the oxygen in the human body. It means categorically it has good molecules of oxygen. Number two, there are at least 1.5 million nephrons in each kidney. So it means that there are a lot of polyunsaturated fatty acid. So where you have a lot of polyunsaturated fatty acid and you have a lot of oxygen, you have created a panacea for free radicals attack. Okay, so the kidney is also unusually prone to free radical damage. It means that it is capable of being attacked. However, I must also say that the commonest cause of end-stage renal disease of kidney failure in the whole world is diabetes. So it also means that whether it's a kidney transplant, that patient that is needed, or somebody on dialysis, your medical doctor, your physician knows best what the treatment. So don't expect me now to say that, okay, like somebody met me the other time, the doctor has said that she was supposed to have the lump removed, and she was asking me whether she should use RiboCeine to treat lump. No, I said, go and do exactly what your doctor has told you to do. So what it means that the raising your glutathione level, it will help the assault. It will help it will help the onslaught of attack generated by free radicals and other toxins on your kidney. It will also help your kidney to recover better. By the way, we are of the opinion worldwide that no new nephron, no new kidney cell, that is the part that actually does the excretion and things like that, is ever created after birth. So meaning that if the kidney, and unfortunately though again, you can lose 70%, 80% of your kidney nephrons without showing any symptom. One day, somebody who has been going with you and you will keep on doing normal tests, and the test will still be coming back and say normal kidney function test, normal kidney function test. But meanwhile, a lot of the kidney cells are dying. So what I'm recommending here is that let us just find ways of protecting our nephrons. Like I told my class this morning that I don't know, maybe some of them are on this call. I said, look, nobody knows your body more than yourself. I'm a professor of medicine, but you still know your body more than me as a professor. So you can actually protect yourself little by little from the onslaught of the chemicals we have in the air, a lot of electromagnetic radiation. Plastics are all over. We use plastic, we dump them inside the ocean. The ocean eventually brings the plastic back to us through plants taking them up, through fishes taking them up. We eat those fishes. Plastics are coming back to us. Electromagnetic radiations are all over the whole place. So we are every day exposed to radiation and toxins that are capable of generating free radicals in our body.
Great. So I'm taking the questions one by one. I think it's going to be easier. If you've got a question, just try and type it into the chat for us. So Dr. Stella has a good question for all of us, really, who are even lay people. What I love about your science presentation tonight, Prof, is that even for those of us who are not scientists like me, it gives us such great confidence that there is so much wealth of science behind what we have. So it's really great. So the question that Dr. Stella has is, if glutathione recycles itself, why does it get depleted?
Yes, thank you. Glutathione recycles itself. Why does it get depleted? Because the components that glutathione itself uses gets depleted. Glutathione is made up of glutamic acid, glycine, and cysteine. Cysteine especially, like I said, cysteine has now suddenly, we have moved cysteine. Before now, cysteine, we categorize cysteine as being non-essential amino acid. Essential amino acid that you have to take in, the body doesn't make enough quantity. So cysteine is now known as, has now been grouped into conditioned essential amino acid. Even though not essential, it becomes essential because it's used by a lot of pathway in the human body. Because the body doesn't make enough quantity under stress. And ladies and gentlemen, who is not under stress in this world now? The rich is under stress. The poor is under stress. Everybody is under stress. The mere fact that we are talking, we are under stress. So there is no way you have enough. And because you don't have enough cysteine in your body, your glutathione level will keep on. And then again, maybe more importantly, by the way, your body is not 100% efficient. Let me tell you what I mean by that. There will always be generation of waste. So if you take in 1 + 1, you will expect it to be equals to, it will be 2. It may be 1.5. So there is a wastage somewhere. So that wastage, you need to account for it. For example, when you make energy in the mitochondria, okay, your mitochondria has some holes in it. That's not all the ATP that you created is actually used by the body. Some will go out as wastages. To account for those wastages, you need to take in raw materials to make more glutathione.
Excellent, thank you. We have a couple of questions relating to liver disease. Let me just see here. So, oh gosh, we have a lot of questions. I don't know if we're going to get to all of them. Let me see here. Hi, lost it. Okay, so we have one question relating to hepatitis B and another question relating to viral load and liver disease. So maybe just talk about viral load and liver disease since those two questions are related for just a moment.
Thank you. One of the major things, by the way, that glutathione does is to help your immune cells to function better. As a matter of fact, categorically, you cannot have highly efficient and effective immune system without glutathione. It's not possible. In terms of liver disease and viral, generally, viruses, glutathione is not going to kill viruses. But what glutathione will do is to enhance the capabilities of your immune cells. Enhancement in the sense that to help them becoming more alert, to recognize quickly that these viruses are there, and to be able to engulf them and incapacitate those viruses. That is what glutathione would do. So glutathione modulates the functions of the immune system. Sometimes, funny enough, glutathione not only raises the alertness, it can actually bring down a little bit overreacting immune system. Ladies and gentlemen, if you are a medical doctor here, you probably have had cases of status asthmaticus. Studies have been documented over and over. You can check that, look, when you expose these patients to more intracellular glutathione, you are likely going to resolve that asthmatic case. These have been well documented. So what that means literally, and that is why I don't use the word it raises the immune system. No, I use the word it modulates the immune system, meaning that it can bring down an overreactive immunity, an immune system that is recognizing almost everything as being abnormal. So it is being too sensitive. Meanwhile, you can have an immune system that is not sensitive at all. In the same vein, glutathione will help. So again, please, if anyone is having hepatitis or any other viral disease, that person also must see his or her doctor and monitor the viral load. I mean, the person also will take the antiviral agents that have been recommended by the physician seeing you. Thank you.
Great, thank you. There's a lot of questions here. I'm going to see if Dr. Edward, if I can unmute him for just a moment. I know he's been marveling at everything you've had to say, and I want to see if he is here. He is. Let me see, Dr. Edward. Let's see if you can unmute yourself. Okay, there you are, sir. Go ahead and ask your questions. Try to keep it not so scientific. I know you've got a lot of questions, but we're a mixed audience here. So you can go ahead and ask Prof a question or two. We're not hearing you.
Okay, thank you.
Yeah, go ahead. Yes.
Okay, first of all, I would like to say I was very impressed with your presentation. Congratulations for that.
Thank you.
It has been impressive and informative. As you have trying to speak about the tumor markers, also the role of RiboCeine in managing those who are having cancers. So I came up with one impression, especially in those who are having benign prostate hyperplasia. Especially, we know that in most of people in Western countries, or also in Africa, are having this problem of benign prostate hyperplasia and are ending up in clinical disease like prostate CA. So is there any way where that this RiboCeine can help to prevent or reverse the progression of pathological benign prostate hyperplasia to the clinical disease? And again, for example, also the second question is, we are having people who are having depleted beta cells, especially in the pancreas, and ending up with the diabetes mellitus, whether diabetes mellitus type 2 or type 1 or the rest. So is there a role that can help this patient or these individuals from, or can benefit from these RiboCeines, as you have explained in your molecular levels? So I would like at least to know a little bit from this, if you have any idea.
Yeah, thank you. So let me take them one after the other. In terms of cancer, one of the things we have found out is that I want to try as much as possible not to be too biological because of our mixed audience. You know, one of the major things we have found out in development of cancer, of course, we still say that the exact cause of cancer, we don't know. Yes. However, certain things have been implicated. One of the major things that have been implicated to date in terms of the genesis of cancer is the attack on DNA. when DNAs are damaged, what are the major things that are damaging DNA in the world generally? Radiation, free radicals. Those are the major things that are damaging, chemicals. But whatever the damage, whatever the major causative agent, eventually, what is going to lead to is actually generation of free radicals. Okay. However, the body has the capability, what we call them the checkpoint proteins. Checkpoint proteins are like policemen to say, oh, this DNA is bad. Don't come inside this cycle. I don't want to replicate you. However, sometimes these checkpoint proteins fail. So bad DNAs, they come into the cell cycle, they are replicated, and cancer can develop. So what can we do in our own little way to prevent this damage? Since we know whether it is chemical, it is toxins, it is radiation, it is plastics, eventually, I call it the common pathway as we know it today is going to be free radicals. So what do I do to protect myself? In a little way, I raise my glutathione level. It will certainly, it will help. Rather than folding my hands and saying, oh, we don't know the cause of cancer. By the way, there's a rule of the thumb for prostate cancer. Meanwhile, prostate cancer is the commonest cause, is the commonest cancer in males all over the world when you remove cancer skin. So it's also in our environment. In fact, pathologists will tell you that by the time somebody is 80, that 8% would have developed cancer of the prostate. By the time somebody is 70 years old, 7% would have developed cancer of the prostate. By the time somebody is 60, 6% would have probably developed cancer of the prostate. So it's fairly common. I agree. Then the next one is diabetes. The diabetes one is very interesting. We discover one thing in diabetes. There's a stage we call pre-diabetes. Pre-diabetes, as the name implies, is a forerunner of diabetes. But the good thing here in this forerunner, we can delay the progression of pre-diabetes to diabetes. We can also, we may be able to halt it. We don't know yet. But what is common to pre-diabetes state that we have found out? Two things. One, unprecedented high level of free radicals. Unprecedented low level of glutathione. Common sense to reason for me. If these are the two things we have found out, that if care is not taken, may eventually progress to full blown. Like I said, at this stage, for glucose transporter 4 to move from this cytosol within the cell to move to can open the gate for glucose to come inside the cell as it should be. Glutathione is necessary for that movement of the transporter from within the cell to the wall. So if you keep on flogging the patient with insulin and the patient doesn't have enough glutathione, there won't be movement of glucose transporter 4 from the cytosol to the cell membrane to open the gate. So you are just flogging with insulin, nothing's going to happen because the man or woman is deficient in glutathione. So what do? Raise the glutathione level and then your insulin may work. So we can actually halt theoretically, but definitely we can actually delay the progression of pre-diabetes from research. I'm talking extensively from research now. That is what we have found out in research, that look, you can, two things common again, high level of free radicals, low level of glutathione. So if these are the two things common, then, and we can attack those two things, I believe strongly that we may be able to halt or we may be able to delay the progression to full diabetes. That's my opinion.
Thank you very much, Prof. On that note of the transporter, someone had asked if that's equally applicable to diabetes type 1 and type 2.
Yes. The it applies to whether we are talking of type 1 or type 2. However, we all know that in type 1, one thing that is common in type 1 is that, look, these patients, we take it for granted that the beta cells are already destroyed. So they don't even have beta cells to secrete insulin already. Unlike type 2, that we believe that the beta cells are there, okay? The insulin, sometimes type 2 patients may even have more insulin, okay? So what we are saying is that irrespective of the case, for you to have movement of the transporters, you need glutathione. So irrespective of whether it is type 1 or type 2. And from our own research, what I do in research, I use the same agents to develop animal model of whether type 1 or type 2. I just vary the dose. I use very, very high dose when I want to completely destroy the beta cells. When I want to destroy some of the beta cells, I use minimal dose to cause minimal destruction. So that is what I do. And I believe that we can extrapolate that really into whether you want type 1 or type 2 responses. Beautiful, thank you. I have two very layman's questions, which will be helpful for a lot of us. One is, can there be an overdose of glutathione? And the second is, why do we not use max products or RiboCeine when we are treating malaria? Okay. Can that be overdose? If it is water, if you take too much of water, as a medical doctor, I advise that you take between 3.5 liters to 5 liters of water every day. The day you decide to take 20 liters, you are probably on your own, because that person can get drowned in his own water. So too much of anything is bad. There is a study available online. They use supradose. See, they use 3,000 milligram of Sergevity. It's available. Go and check it online. You know, I don't even know why ethics allow that. It's like somebody giving a rat one whole bottle of Sergevity. Of course, there will be side effects. So the dosage that we prescribe, 2 tablets of Sergevity in the morning, 2 tablets of Sergevity in the evening. Whenever you want to raise RiboCeine, whenever you want to raise glutathione alone, then you can add Max 1 that has no other, because there are some components in Sergevity that you may not want it to go to, like there's selenium there. There are some other agents that you don't want to raise. Then can there be, the next question is, what was the second
malaria
one?
Treating malaria.
Oh, okay.
Yes. Again, this is theoretical. You see, not all antimalarials, by the way, artemisinin-based antimalarials, we believe that they act by generating free radicals to destroy the malaria parasites. So if you give antioxidants, you are likely going to be providing the malaria parasite with what it needs. That is one side of it. The other side of it is that now let's extrapolate to cancer. Why should I not raise glutathione level for a patient with cancer? Yes, because again, the same principle. Most of the anti-cancer agents, they destroy the cancer cells by generating free radicals. So when you give chemotherapy, radiotherapy, and you are providing antioxidant again, you are like providing the cancer cells what they need to survive. However, there is a caveat now. This is where it gets very much interesting. Some authorities believe that cancer cells are not able, in quote,
to bio-uptake glutathione in sufficient quantity. Meaning that if you give antioxidant, raise the glutathione level, cancer cells may not be able to take those things, but normal cells will be protected against the deleterious effect of cancer cells. But this is a very elementary stage of my research in this area. So we cannot yet extrapolate to treatment. So we still advise, go with the advice of your medical doctor. However, when you want to treat cancer patients, stop your antioxidant, stop your glutathione enhancer, stop your RiboCeine, do the cancer treatment. 48 hours later, you can start. But as you saw in my presentation, when we used dozorubicin, we got better improvement than the cell that had dozorubicin alone, than the one that had dozo and RiboCeine. We got better treatment, even though it was pre-treatment that we did. But again, please, this research, part of research, is still at the nascent stage. We cannot extrapolate here to humans. Thank you.
We do have a set of frequently asked questions, so we'll be happy to share those out. Those are very helpful for everyone, so we'll share those. A question on the brain. So a couple of questions around the brain. One is around RiboCeine's effect on the brain cells, particularly when it comes to traumatic brain injury and recovery. And then somebody else asked for a bit of a discussion on neurodegenerative diseases like Parkinson's or other issues like that. So those are all relating to the brain. Maybe you could take that for a moment.
Yes, thank you. To start with, the brain is unusually prone to free radical damage because the substrate for free radical attack is always there. 20% of oxygen consumption of the body is by the brain. We have billions of cells coming together in the brain, synapses. And when there are cells, there are a lot of cell membranes. And one major component of the cell membrane are lipids, polyunsaturated fatty acid, available in sufficient quantity in the brain with oxygen, 20% of oxygen in the body. You have the panacea for free radical attack. And that is why the brain is unusually prone to free radical damage. Autistic disorders, Alzheimer, Parkinson's disease, other organic brain syndromes, dementia, these have been well documented in literature. Not only to respond to glutathione, let me tell you, in fact, in terms of degenerative, before we have observed, before we even see, in terms of physical time, degeneration of neurons in where we call the substantia nigra of the brain, we actually notice something heralding, predating the commencement of that destruction of dopamine-based cells. And what is that molecular marker that predates it, that is telling us, oh, this patient is likely to have a degenerative disease? And guess what? That is low level of glutathione. So even before we see the destruction of cells of the brain, years before then, you would have seen that tendency. That level of low level of glutathione is becoming more chronic. So, well, my reasoning now is that, look, if you want to slow the senescence that is coming with aging of the brain and things like that, you may need to help yourself and raise the level of glutathione. Because by the time you are 60, you are 70, you've lost over half of your glutathione level. And there's nothing you can do about it. Your body is not that efficient That is the problem. As you grow older, your body loses efficiency. It's not going to function as you were 20 years ago. It's not going to function as you were 30 years ago. The efficiency will reduce. The ability for you to even mobilize resources it becomes diminished. And so you can no longer manufacture glutathione as much as possible. So it means you need to enhance your glutathione level. 6% of your body ATP is used in making glutathione level. So it is so critical for the sustenance of your nerves in the brain. And so I'm not surprised. It's already been documented as well in autistic disorders too, that low level of glutathione is associated with this. And so you can help as well by raising their glutathione level. Thank you.
Beautiful. So I think we're going to round up. There's a few people asking about human trials. Maybe you can talk a little bit about why animal trials, why not human trials, what could the plan be, and the rest.
Let me also do some corrections here. That, funny enough, it may shock you that not all drugs that we even use today have human trials. Not all, you know. But that notwithstanding, I can tell you that I know the result of the human trial for longevity or RiboCeine, which we will do anyway, eventually. Some has commenced already, some have commenced, and we get the report as out as possible. But I can tell you, not all. I teach a lot applicability of animal trials in humans, and what I conclude every time and then is that you cannot directly extrapolate. That being said, it gives us what the human picture is likely going to look like. The difference is not often much, because what affects humans almost invariably affects animals. Nonetheless, the conclusion of the matter is that no direct extrapolation for now. So the doctor as well, we also use his or her own judgment and wisdom to say, okay, oh, I know this helps. Why should I not use it? Why should I use it? So it all, and then of course, again, I'm going to repeat that. You know your home body more than any other person. And the doctor that is treating you knows your body more than me. Thank you.